Everyone's talking about AI, but let's be real. Most developers are still just guessing how it actually works. Welcome to the Explainer. Today we're cutting through the buzzwords. We're going to demystify the 10 core concepts that actually define modern AI engineering. No hype, no fluff. Let's go. And here's the secret. We're treating these as a connected system, not just isolated vocabulary words. Here's the roadmap. We're building from the ground up, starting with the foundation, moving into data integration, tackling autonomy, diving into advanced architectures, and wrapping it all up with the master skill.
Let's kick things off with Section 1, the foundation, looking at LLMs and context.
Concept 1 is LLMs and tokens. Whether you're building with ChatGPT, Claude, or Gemini, they all share this exact same base architecture. A large language model is basically a massive neural network trained to do one deceptively simple thing: predict the next unit of text. So you type, "The capital of France is," and it predicts Paris. But here's the kicker. LLMs don't read words. They read tokens, which are just fragments of words. The word unbelievable isn't one word to an AI. It's actually 3 tokens: un, believe, and able. Scale that simple prediction trick up to billions of parameters, it goes way beyond autocomplete and actually unlocks genuine reasoning.
Which brings us to Concept 2, the context window. This is probably the most misunderstood part of the stack. A context window is basically the model's short-term memory. It represents the strict maximum limit of tokens the AI can process at once. Once a token falls out of it, the model forgets it completely. So if your AI suddenly forgets what you said 5 minutes ago and starts acting like a goldfish, yeah, you just hit the edge of its context window. And honestly, the context window illustrates just how incredibly fast things are moving. Early GPT models, they had a tiny 4,000 token limit. Today, we're working with models that process over 1 million tokens at once. That's enough to feed in entire books, massive code bases, or whole document libraries in a single go. It totally changes the game for how we feed data to AI. Hold on a second. If we have 1 million token memory now, why can't we just dump all our company data into the prompt every single time and just call it a day? That is exactly what we're covering in Section 2, data integration, where we compare RayG versus fine-tuning. Because dumping everything into the prompt every time, that gets insanely slow and wildly expensive. We need smarter ways to do this. So Concept 3 is RAG versus fine-tuning. People confuse these constantly, but they solve entirely different problems. RAG, or Retrieval Augmented Generation, cures hallucinations by injecting missing factual data into your prompt. Fine-tuning, on the other hand, takes a pre-trained model and tweaks it to alter its behavior, tone, or style. The quick rule of thumb: fine-tune a model so it sounds like your brand, but use RAG to give it your brand's latest pricing sheet.
Okay, I get the difference in theory, but when would you actually use RAG over fine-tuning, like in a real functioning engineering product?
Great question. You use a RAG pipeline, maybe orchestrated with a tool like LangChain, when you need the model to dynamically search your internal docs. And to pull that off, you need a vector database and embeddings. Instead of storing data in old-school rows and columns, a vector database stores data as mathematical representations called embeddings. This means you can search by semantic meaning instead of exact keywords. So if a user asks for a refund, the system instantly pulls up your money-back or return policy, simply because the math proves those concepts mean the same thing.
Moving right along to Section 3, autonomy, agents, and MCP. So now we're shifting gears from just retrieving static data to building systems that actually take action in the real world. This is Concept 4, AI agents. And listen, an agent is not just a chatbot. A chatbot tells you how to book a flight. An agent actually goes and books the flight for you. It's an autonomous system that continuously loops through 4 steps: perceive, reason, act, and observe. If you want a deep dive on how this multi-step reasoning actually works in practice, HubSpot put out an incredible free playbook called AI Agents Unleashed that breaks this exact framework down perfectly. To give you an idea of how fast this agent space is exploding right now, just look at OpenClaw. It's an open-source AI agent that racked up 60,000 GitHub stars in just 72 hours. It runs locally and hooks into your apps to act on your behalf. Developers are using it to triage their inboxes, control their smart homes, and literally debug their code while they're asleep. Okay, but how does an agent securely talk to my database, my Slack channel, and my CRM without me having to build 100 custom APIs from scratch? Because honestly, that sounds like an absolute integration nightmare. It definitely used to be, but that is exactly where Concept 5 comes in, MCP, or the Model Context Protocol.
Think of MCP as the USB for AI. Before USB, every single hardware device had its own proprietary connector, right? Well, before MCP, you had to build custom integrations for every single data source. Anthropic actually donated MCP to the open source community, and it acts as this universal adapter. It completely standardizes how models securely connect to external software. Make no mistake, this is rapidly becoming the future of how AI talks to software. All right, Section 4. Let's look under the hood at advanced AI architectures. What's actually powering these autonomous, tool-wielding agents? Concept 6, reasoning models. Your standard LLMs respond instantly, just spitting out tokens, one after another. But reasoning models, like OpenAI's O-Series or DeepSeek, use reinforcement learning to literally think step by step. They break the problem down, generate an internal chain of thought, and work through all the logic before they give you an answer. When you use an AI and it pauses and says, thinking, you're watching that internal loop happen in real time. Concept 7 is multimodal AI. This simply means the model natively processes text, images, audio, and video. It handles them all as inputs and outputs. What's absolutely fascinating here is that when you train a model on both images of cats and text about cats, it develops a way richer semantic understanding than a text-only model ever could. This makes multimodal models perfect for really complex applications, like medical systems that need to analyze visual scans right alongside patient notes.
Concept 8 is mixture of experts, or MO. This concept has actually been around since 1991, but modern models like Mixtral use it as a hidden architecture to keep AI costs from completely spiraling out of control. Instead of firing up one massive neural network for every single prompt, Mo divides the model up into specialized subnetworks, the experts. Then, a routing mechanism decides which experts to activate for your specific query. The result? You get the massive intelligence of a huge model, but with the lightning speed and cheap cost of a much smaller one.
Finally, Section 5, the master skill, context engineering. We've covered all the underlying components. Now it's time to synthesize them. Concept 9, context engineering. Now this goes way beyond basic prompt engineering. It's about meticulously designing the entire information environment around the model to maximize output quality. You are intentionally curating exactly what enters that short-term memory window we talked about at the beginning. Which leads us to our final concept, number 10, the unified system. Building the perfect engineered context window requires treating all these concepts as one cohesive stack. You use RAG to dynamically fetch facts from your vector database. You use MCP to give the model secure access to your external tools. And you weave all of that together with precise conversational history. That entire complete package, that is the engineered context. The stakes here are absolutely huge. Two different developers can use the exact same LLM, but get wildly different results purely based on their context architecture. The engineers who master context engineering, those are the ones companies are literally desperate to hire right now.
Exactly. It all comes down to how you build the system around the model. So I'll leave you with this final provocative thought for your next project. Are you just typing blindly into a prompt, or are you engineering the context?